Hello, everybody. So, kind of want to stop right now and do something a little bit different and show you on a whiteboard what all these things actually mean. Okay, so let's take first step is glycolysis. Glycolysis. Okay, we'll cover that. Then it's going to be the Krebs cycle. Actually, we'll highlight the transition step here, and then finally, what I call the Krebs cycle. And finally, the electron transport chain. Okay. All right. Glycolysis. Okay. It always starts C6H12O6. Okay. Glucose. Okay. Gets converted into 2 pyruvate plus 2 ATP plus 2 NADH. Okay. So, okay. So now I'm going to take pyruvate and we'll use this in my transition step. Okay. So text. Pyruvate will be, the transition step will be pink. So 2 pyruvate plus 2 OA goes to 2 acetyl CoA plus 2 NADHs plus 2 CO2. Okay, so again, I'm generating more NADHs. So 2 plus 2 is 4. So now 4 NADHs. Okay. So draw circles. I'm going to put the NADHs in green here. So 2, 2. Okay. Okay. Now the ATPs will be light blue. So blue. Okay. Okay. Now the next step is red. So the Krebs cycle will be red. So the Krebs cycle, I'm going to use acetyl CoA. So acetyl CoA is there. And I'm going to put it into the Krebs cycle. So Krebs cycle. Okay. Now 2 acetyl CoA. Acetyl means it has 2 carbons. That gets broken down into 6 NADHs plus 2 FADHs plus 2 ATPs plus 4 CO2s. Okay, so again, the blue is an ATP, the green is an NADH, and we'll make this the dark green. Oops. Two fingers. Oh, right. Okay, good. Okay. Okay, so there. Okay. So the last thing, the oranges are always CO2s. Okay. So these two get breathed, these 6 CO2s get, breathed out. You breathe them out. Okay. So yeah, let's count out everything. So 2 plus 2 plus 6. Okay. So the electron transport chain, I will put in the wall. Okay. 10, not red, purple, or brown. Okay. 10 NADHs plus 2 FADH2s. Okay. Supposed to make 34 ATPs. Okay. 3 per NADH, 2 per FADH2. Okay, so now let's count the total number of ATP. Okay, so again, I want you guys to know the inputs and outputs, so like everything on this page. Okay, so let's count total number of ATP. Okay, so 2, 4, 38, right? 38 total. 38. Okay. All right. Hopefully that makes sense. Okay. Okay. Proteins and fats can enter the energy extracting pathways. Okay. As well. So sugar, all the sugars will come down this main pathway. The fats go into pyruvate, and then fats go into acetyl CoA. So like they can enter these pathways. Okay. The amino acids can enter at every step. So some amino acids, the first thing you have to do with amino acids is strip off the nitrogen. And the nitrogen you basically pee out as urea. But the rest of it can go into all these different ways, and you can make energy from everything. Okay, so we prefer to get energy from sugar, okay, and fat, but we can also get energy from protein if necessary. Okay, all right, so the last part of this presentation okay. Okay, the last part of this presentation, okay, is anaerobic respiration. Okay, anaerobic respiration. Certain organisms can survive in the absence of oxygen. Glycolysis produces ATP without requiring oxygen, but it makes very little. Okay, and that process is called fermentation. Okay, many prokaryotes and some eukaryotes use fermentation. Okay, In fermentation, there is no Krebs cycle or electron transport chain. Okay. Fermentation simply allows glycolysis to occur over and over and over again, and that produces small amounts of ATP. Okay, so we generate 2 ATPs in glycolysis. We also generate 2 NADHs. But here's the thing: we need the NAD plus back. So we have to take the electron from the NADH, do something with it. Okay. Okay. So we need to reformulate the NAD plus, and so what we do, okay, we use pyruvate. We oxidize pyruvate. Okay, we drop the electrons back onto pyruvate, and then the pyruvate is converted to either lactic acid or indirectly to alcohol. Okay, yeast, okay, make alcohol, so that's alcohol. And in humans, we make lactic acid. Okay. Okay. So we use yeast to produce alcohol, so that's alcohol. Okay. And then humans build up lactic acid. Okay. Lactic acid can be converted back to pyruvate when there's oxygen available. So lactic acid is a temporary storage. Okay. We can convert it back to pyruvate, and then from pyruvate, we convert it back to sugar, all the way to burn it again. Or we can just burn pyruvate. Okay. All right. So the main advantage of fermentation over cellular respiration is that I can generate ATP even when there is no oxygen. So if I'm running as fast as I can, or I'm lifting weights that are in a like competitive sense, like lifting a lot of weight, I actually the weights I'm lifting use more oxygen than I can possibly provide. So I actually go into anaerobic respiration. So I'm sure you guys heard the term aerobic exercise and anaerobic exercise, right? So, all right. There you go. Okay. All right. That ends the presentation. Okay.